يا أهلا وسهلا عن جديد.
طيب يا أسامة، عندي 4 آداب التلاوة قبل أن نقرأ القرآن من يجب أن نفعل؟ نتوضأ ونقول.
Please can you turn off your mic? يلا 1 minute لحتى اللي يفوتوا بعد، في عندي 10 أشخاص ما فاتوا. اوكي سو عمليا الكل موجودين بالشات روم بالويبينار، عندنا 40 دقيقة نكمل فيهم. سو كنت عم اقول I was saying that once we go and we make a flashback to the input-output device of the computer, it's normal and it's very simple to link to the robot and to explain them the components of a robot that are common for all robots, even if are real robot in industries and medicine and services, or educational robot. So the brain, the output device, the input device, the skeleton, and the software. Then after, for the second lesson, we'll go for directly to choose the robot for educational robot. And here you have to explain to your student that it's impossible to bring a real robot at school in order to show them how it functions. That's why we adopt what we call the educational robot. I know that there is many educational robot in the market used by maybe by school, but the first robot, the first educational robot that is used by school and that is really educational, and I will show you why it is educational and why it's number one. It's the robot EV3 from Lego. Okay, I guess many of you know the robot. It's this robot. Okay, the EV3 robot. Please, can you turn off your mics, please? Can you turn off your mic? Okay, so the main question is why the EV3 logo is the number one educational, and we are, I advise you to adopt. First, because it is integrated in the program Scratch, the new version of Scratch 3.0, and we know what is Scratch for programming. It is adopted by Microsoft, by the software make code that I will show you right now. This robot has advanced feature programming like integrating variables, arrays, Bluetooth connectivity, all the mathematics functions and formulas. So that's why this robot is considered as the #1 educational robot in the world. And of course, they have an API link to program this robot using the small basic and Python language. Okay. This link also I will send it to you by chat, and you will discover it later on when I send you the just a moment. The chat room is opening.
Do I know that how many real it will spend for to buy this EV3?
Sorry?
I just want to know that EV3 hardware, that the robot, how much real it will spend to buy?
Really, I'm not
asking about the price of the EV3 robot.
actually. I don't know the price. You have to contact. I can help you finding the official distributor in your country where you are at school, but I don't know why the chat room is not open. In all cases, you will have the link later on that shows you the hardware of the robot, mainly in a quick way. You have the brain, you have the sensors, the ultrasonic sensor, the touch sensor, the color sensor, the gyro sensor. It's not included here. You have the motors, large motor, and you have the medium motor, and of course brain with the screen and the microphone from this side. So my target now is not to show you the hardware, since I consider that you are teaching your student on a distance learning strategy. That's why you have to send them the link you see in front of you, and then the student will have an idea about those components. Now, the interesting part is to show them and to start programming this robot by creating a robotics mission. And here, for a distance learning, you have two solutions. The first solution is the official software of Lego, which is the Mindstorm that you can see on your screen. And the second one is the software make code for Lego. The difference between them, that the Mindstorm, it's a wonderful software. I will give you an idea about it. The problem is there is no simulator. So if you program on this software, you cannot show your student a simulator on screen to see if it's working or not. But it's based on logic and on coding and on concept of creating this link between the input device and the output device. And to tell you that, and I guess you know this, that when we talk about Internet of Things or artificial intelligence or machine learning, it's all about to link the input and the output device of a machine or a robot. It's so easy. So let's say we order a motor to start if the temperature is higher than 30 degrees. It's very simple. So that's why those concepts could be really made clear in any of the two softwares. But the difference is that on the Mindstorm, you don't have a simulator on screen to see the result. So there is no simulator, is not available. But for the make code software, you have a simulator, and you can see it here on the left of the screen. Now for the make code, I don't know why I cannot open the chat room. a little bit weird. In all cases, for the make code, you have two versions. You can download it on your computer, or you can run it via a browser. It's very simple. Okay, so
It's upstairs, mister. It's upstairs. You can find it upstairs. To the right,
yes,
beside the sharing. Beside the sharing upstairs. If you click up to the share screen or stop sharing, then up to the right there will be three points. You can click and open chat.
yeah,
I'm
clicking, but it's not opening. I don't know why. I will stop sharing. Now it's opened. Okay. So this video will be later on. You can see it. Okay. So I will open the. I will share for you the the make code. The make code which is run under the web. It's not installed. Please, can you tell me if you can see it?
Yes.
Okay. So
Yes,
this software, you can have the offline version, and you can have the online version. It's up to you to send to your students to download it or to view it from browser. And as you can see, the idea of this software made by Microsoft, you can see on the right, it's Microsoft, and on the left, it's Lego Education. So when you see that a giant company like Microsoft adopted the Lego Mindstorm to create the software to learn and to teach students robotics, it means that the EV3, it's #1 in the world to make them understand what is robotic and so on. So it's like Scratch. It's based on blocks. Of course, you can switch the tab to JavaScript, but of course, it's not our target to learn robotics in JavaScript. So as you can see, it's very complicated for kids. So I will switch back to the blocks. And as you can see, this software, one moment, please. As you can see, this software is based on blocks divided by category, like in Scratch. I will not go in detail through all the blocks right now. And as you can see, the blocks are easy to build. The missions and the scripts are easy to build. Here on the loop on start, I order my robot to switch the green, the light here, as you can see, to orange. I can switch it like to green, for example. And in the forever loop, okay, I ordered the robot with the motor B and C. Those are running here at a speed of 50 to run, and a condition is built in the forever loop asking if the ultrasonic sensor that you can see here is less than 10 centimeters, okay, it will play the sound, the animal cat purr, and it will stop all the motors, and it will pause until the distance is greater than 10 centimeters. So as you can see here, the motors are running. The ultrasonic sensor is detecting a 127 centimeter. If I reduce the distance to less than 10 centimeter, a sound is reproduced and the motors are stopped. And if I go back and I make it bigger than 10 centimeters, the motors will start again. So I try to show you that this software, where the blocks are divided into bricks, into sensors, into motors, into music, into loops, into logic, into variables, into math, and all the math function, and even we have what we call the advanced function, like the, the arrays, the control, and the extensions, is really it's really a software that to be considered to teach your students distance learning. I understand well that it's a challenge for you. That's why since I have schools that are adopting our curriculum right-click, we will be proceeding starting from tomorrow to prepare educational worksheet to be sent to your students in order to work on the make code software, which is not built in the books till now. Okay, so the first idea is to show them the make code software. Then after, I will go through the Mindstorm software. I hope you are seeing the software Mindstorm on your screen.
Yes, it's visible.
Okay, so this software, it is free. You can download it on your computers, even if it's Mac or I will, sorry. Okay.
You're welcome.
Okay, and this software also can make students understand the link between the input device and output device of the robot. As you can see, this software also is clear. Once I create a new project, as you can see here, you can create more than one program if you wish. It's not the time for to go through all those details. All details are included in the right-click box. So I will show you the category of blocks inside this program. So you have the action block, you have the flow control block, you have the sensors block, you have the data operation block, you have the advanced block, and the my block to make a macro. Please, can you turn off your microphone, please? Can you turn off your microphone? Please, can you turn off your microphone, please? Okay, so based on that, okay, those blocks can be programmed in a way to create a specific mission. And even if you can't practice, since you are on distance learning, or even you don't have right now the robot with you, you have to understand that the same concept is considered.
Anyone?
Sorry?
Please, all of you, put your names as it is. Don't change. Don't change. Don't write Hasna or anything. Because here, there's some students who are joining from outside.
Okay, so the same concept of programming, even if you are using Mindstorm or Make Code, is the same. So let's show you how easy we can create a specific mission to order a robot to move forward a specific distance. So from the move tank, I select the block move tank. I set the speed of the robot, and I set the duration or the rotation of the wheels. Here it's for one rotation. And if you want to link this concept with what we call the STEAM education, it's really interesting to show the students that if you select the setup button here, you can see that you can configure your block move tank into off to make the robot stop, into on to make the robot move forward and not to stop unless there is a block to stop the robot. For seconds, I want my robot to move forward, let's say 5 seconds. 4 degrees, how many rotation in degrees, or 4 rotation. And as you can see, you can't see that we can make the robot move for a specific distance in centimeter. It's normal since this robot or this motor, we can control the rotation. And if I remove the wheel and I replace it by a bigger one, so the diameter of the wheel will change according to the size of the wheel. That's why here we are talking about a rotation. I mean, one rotation. This is one rotation. This is a second rotation. And for each rotation, as you can imagine, in math, it's equal to 1 perimeter. And the perimeter is made by a formula pi times 3 the diameter, and that's why here the robot, the diameter of the wheel is like for 17.6 centimeter. So if you choose one rotation, this means the robot will move forward for 17.6 centimeter. And this is really challenging for students to make a small calculation in order to understand the link between the math, the perimeter, and the wheel of a robot. And you can ask them to move forward, for example, 50 centimeter, how to make the calculation. So it's easy to make it and to put here, let's say for 2.3 rotation. So here the robot will move for 2.3 rotation. It will stop. Then it will reproduce a sound, hello. And then after, it will change the light of the brake for, let's say, for red. And from the control or the flow control blocks, the robot will wait for 3 seconds. And then after, I will select all my mission. And then after, the robot will move backward, like for a speed of -10, and then it will wait. It will wait not for a time. If I click on the setup button, as you can see, it will wait the color sensor, the gyro sensor, the infrared sensor, the motor rotation sensor, or the ultrasonic sensor, which measure the distance that we saw in the make code program. So I select the ultrasonic sensor, and here, if the distance is less than 35 centimeters, then the robot, let's say, will turn or will spin at a speed of -50 for one rotation. So what I'm trying to show you that the concept of programming a robot is not really difficult. What is difficult is to make them understand this relation between the input and the output device, and to read an algorithm and to convert it to a mission. I mean, later on, you will ask your student, for example, make the mission that make the robot move, stop, play a sound, spin, wait for the touch sensor. So a series of actions written, and the student must convert them to a mission. Even in the program Mindstorm, or even in the make code program. I remind you that the difference between the two programs is that the programs, one, we have a simulator, and the other, we don't have a simulator. So it's an advantage for you to use for the time being on distance learning the make code software with the simulator. And I remind you that by using our curriculum right click, you will receive for free additional worksheet to send to students in order to practice robotics online. So I will continue with my presentation. The second lesson will be the software, sorry, make code. The second lesson, I'll go back a little bit. So just to remember what we did in the second lesson. Okay, so quick review. Input output device of a computer, the main component of a robot, why we adopt EV3 Lego. You will show them this video about the hardware of the EV3. You will introduce them to the EV3 Mindstorm robot with a few examples as I did right now. And the software make code with the simulator. And the third lesson will be the moving concept, as I showed you just right now with the Mindstorm, how to move forward, backward, to make a spin, related to the other blocks to make sound, and to stop for a few seconds, or to stop until we make our hand to reach the ultrasonic sensor. The fourth lesson will be the loop and the concept of the loop and how to control a robot using a loop. The fifth lesson will be introducing to sensors and the importance of sensors and what we have sensors in the EV3 robot. That are the ultrasonic sensor to measure the distance, the touch sensor, the light sensor, the color sensor, the gyro sensor to measure the angle of rotation. And of course, we can consider that the touch button or the brick button here are considered as a sensor. I mean, if I click on this button, the robot will take this action. If I click on this button, the robot will make another action. Now I will show you the
Mister, can you share the screen, please?
I'm not sharing the screen.
No.
No. I was showing you the robot. Sorry, the PowerPoint. Excuse me. Okay. So I was saying that the fifth lesson will be the third lesson will be the moving concept. The fourth lesson will be the loop, and the fifth lesson will be the sensors. Now, what is really interesting in this webinar, that I will send you the link of our YouTube channel, where there is several of YouTube tutorials for many topics, and among those topics there is the robotics topic, where if you
think you have just 5 or 6 videos, and we need the link to download the program, please.
Of course, the program I will send it once I finish. I will send you the recording of this session, the software link. I'm writing right now the software link, and the YouTube channel, and all the materials you may need for discussed in this session. So I was saying that we don't have all time right now to discuss or to show you in detail the concept of programming, but the advantage is that all those concepts and how to conduct a lesson are on our YouTube channel, where you can see in a progressive way, in detail, in a well-made technique, and in an educational technique, how to conduct a lesson step by step. And you will see that it's really easy to teach this concept of robotics for students. So right now I will try to link you to the book of the first level of grade 4, to show you that really it's progressive, it's educational. If your students have the book, and you can share with them the online flip book, I sent you the link previously for all the person who are using our curriculum. So as you can see in the first lesson, sorry, in the first lesson here, it's introduction to robotics. We define what is a robot. So the answer to the main question we gave in the first lesson, where to find a robot, the second question. And here you are obliged to make a discussion between you and your students in order to make the lesson a little bit attractive by showing them picture and maybe videos and so on. And the educational robot, we have two main educational robots that are Lego and Vex. And for our curriculum, we choose the Lego robot. And I told you and I showed you why we took this decision. Of course, after that, the 5 main parts of the robot, which are the skeleton, the brain, the motors, the sensors, and the Lego Mindstorm. And here there is a picture of the different components that they will see in the video that you send the link. And you will finish the first lesson by a true or false exercise. The second lesson is for the icon of the robot, and here is the link to the software. I will send it to you just right after this session. And they are explaining to students what are the components of the welcome screen, how to create a new program, how the blocks are divided into different categories. And of course, the right pan here, the right windows, we did not discuss it since it's an online distance, and how to link the robot to the computer by a USB cable, and how to download the program. The next part of this lesson will be to take the action block in order to make them understand how to make the robot move. And here there is an exercise about how to turn off the motor, to set it on for seconds, for degrees, and for rotation. And we end the second lesson by a simple exercise to match each block with its functionality, which is to turn, to move forward, to move backward, and so on. The third lesson will be to discover the sound blocks, and to play music, and to display information on the screen of the robot. As you can see here, we show them how to play sounds, how to make the robot display music, and how to display figures on the screen. All those concepts could be made on the Lego Mindstorm or on the Make Code software with the online simulator. Okay, and at the end, here is the mission written as an algorithm, and the student is asked to convert it to a mission. Then after the lesson 4, I guess, it's how to make the robot move, make a movement by selecting the duration or the centimeters, and by creating experimentation. All those lessons are well explained on our YouTube channel. If you select the robot section, that I will send you also the link. Here we are making experimentation how to make the robot move 20 centimeters and how to make the calculation and even to make the rotation of a robot. And the sixth lesson will start by controlling the movement of a robot using the what we call the sensors. And here we are working with the color sensor. So also there is a detailed step-by-step to select how to make the robot move. Okay, I will show you right now how to build the mission. And after that, we have a mission to perform where the student is asked to build a series of blocks in order to make this this mission. So I will share with you again the Mindstorm software. And in the Mindstorm software, I will build my mission that the robot will move on, it will not stop, and then the motors will be turned on. The wait block will wait not 4 seconds, but for the color sensor to detect the color, let's say green. I will select the green light, and once the color sensor will detect this green line, the robot will stop. So this mission will link the input and the output device of a robot, and the robot will move forward, okay, and will not stop until it detects the green color. Once detected, the robot will stop. So this is how we can control the robot by the color sensor. And after that, it's a advanced mission where the student is asked to create this mission with all this algorithm. It's not really difficult if you go through step by step. And this mission also could be done in the make code software. So after that, we have the last lesson in robotics for grade 4, which is to control the movement of a robot using the ultrasonic sensor. Of course, it's the same concept, but instead of making the robot wait the color sensor, we ask the robot to wait the ultrasonic sensor to detect a specific mission. I forget to tell you that robotics in a curriculum should be given about 6 to 8 period per year, not more, like about 6 to 8 period, since we have other topics to give to students. I gave you an idea about how to conduct a lesson in robotics for grade 4. So if we took, I have less than 1 minute. I will continue, please, for all those who will join. I will ask you to, since I have less than 1 minute, I'm sorry. So go back to the link to continue, not for 40 minutes, less maybe, to finish what I was planned to do. Okay, please. So I will wait you. I will wait you to join same link, please.